So yesterday we were practicing a little bit of factoring. So we had looked at one where you had to factor out the greatest common factor first. We're going to look at more of those today. We're also going to look at the swing method. I think Ms. Vessel taught you guys that in Algebra 1. The book does factoring by grouping. So the book will do a different method. You can certainly use that. That's actually how I learned. But I'm going to show you the swing method because I really think that it's just as easy. So it's something different, and sometimes if you don't understand the book, something different is good. So when we're looking at this one, the first thing you want to do is look at the numbers and think to see if there's anything you can take out. So mainly the number that you really want to get rid of if you can is the number ahead of the x squared, because then it will be an easier, you'll have an easier time factoring when it's a 1. So can we take a 4 out of 20? Yeah, can we take a 4 out of 56? Probably. It's 14. So I'm going to factor out a 4 first, and you do have to leave it there. And remember, when you're taking a 4 out, you're really dividing each of the numbers by 4. Then we need factors of which number, 5 or negative 14? Factors of negative 14 that add up to 5. There aren't very many, so we need factors of negative 14 that add up to 5. When this number is negative right here, what kind of signs do we need? 2 of the same or 1 of each? 1 of each. So signs, 1 of each. Then you look at this number. The largest one has to be that sign. So largest has to be positive. Okay, so my factors are 1 and 14. Again, the largest one is positive, so I wrote it that way. When I add negative 1 and 14 together, I only get 13, so that's not the one. The other factors I can think of are 2 and 7. Biggest one positive, smallest one negative. When I add them together, I get 5, and that's the one. So you can stop once you hit the right one. I know different books make you do all the factors and then do the sums. Don't do that. Once you find it, do the sums right away, and once you find it, you are done. And if you can find it in your head, that's totally fine. So sometimes there'll be a number. Sometimes there might be letters too, variables sitting outside there. If there's x squareds, or like if it was x to the 4th, x squared and x, you can take out the x. You can take out as much as you possibly can, and the stuff that's left you should be able to factor a little bit simpler. So let's practice these two. So these two are just like the two we just did, one from yesterday, one from today. When you're looking at the first one, it only has 2 terms. That's kind of should be kind of an alarm going off in your head that it won't have 2 sets of parentheses. It might just have 1. It depends on, what it looks like. So go ahead and try A, go ahead and try B, and then we'll go through them together. So what did you guys take out of A? 7. Now, can you do anything with n squared minus 3? No. You could if the 3 was like a 9. Then it's the difference of 2 squares. But we could take it a little bit further if they really wanted you to. You would go n minus the square root of 3, n plus the square root of 3, but the book leaves it just like that. So they're not necessarily taking this that far because it's just, take out what you can. So we'll leave that one for now. The second one, is there anything you can take out of this one? 9. And when you look at the letters, there's not a letter with 18, so you can't take those out. Can you factor what's left? Okay. So we need factors of negative 2 that add up to 1. Since this one's negative, we need 1 of each. Which one is positive? Largest one is positive. Okay, so the only factors of 2 are 1 and 2. Largest one is positive, smallest one's negative. When you add them together, you get 1. So it would be minus 1 plus 2. Oops, I forgot my x on that one. And the order is okay if you have them switched. So you could have 9 times x plus 2 times x minus 1. The 9 is usually written in the front, so if you have a number, write it in the front. The other factors, the order doesn't matter as long as you have each one. That's what I'm looking for. Okay, now there's one more. So can we take anything out of this one? 4. So when I take a 4 out, x squared plus 2x plus 3. So we need factors of 3 that add up to 2. The only factors of 3 are 1 and 3. Notice that they're all positive, right? So this, they could be 2 positives, 2 negatives. But since this one is positive, you have to go with the 2 positives. So when I look at this one, I get 1 and 3. But when I add them, I get 4. But is that my only option? But then you'll have a negative something in the middle. So you really can't. So when you have stuff like this, that there's no possible way that you can do anything with it, it's done the way it is. So really the only thing we can do with this one is take the 4 out, and the rest just has to stay. This would be something that if you did have to take it a little further, you'd probably have to use the quadratic formula or something, and you'd get some decimal-like answers, which right now when we're factoring we don't need. Okay. Here is the swing method, different from the book. The book method is factoring by grouping. What they do is they look at 2 numbers that add up to 11, and then they do a factored version. It's different. So I'm going to do the swing method because I know that you guys have seen it before. You're going to use this method anytime the number ahead of the x squared term is not a 1. We already know how to do the ones. Now what do we do when they aren't a 1? What you're going to do is you're going to multiply these two and change it so that you're going to factor a new expression. Okay, so you're going to multiply the 2 and the 12, and you're going to get 24. So now it's a new expression that we're going to factor. It looks like that. So multiply the 2 at the beginning and the 12 at the end. Now the 2 at the beginning, I'm going to circle this one in a different color really because you do have to do something with it at the end. So I'm going to go with green. Okay. So we're still going to do the same thing that we just did. We're going to do factors of 24 that add up to 11. Anybody think of it right off the top? 8 and 3. So if you can think of it, do it. If not, you're going to go 1 times 24, 2 times 12, and keep going. Three times 8. This would be 25, 14, 11. So this is the one. So you get x plus 3, x plus 8. Now, when you look at this one, we can't stop here because we changed the expression at the beginning. We took that 2 and we moved it somewhere else. So now we have to take care of that 2. So what you're going to do is you're going to bring it down and divide whatever numbers you get by 2, and that's where this is coming from. So far it looks like x plus 3 over 2, x plus 8 over 2. If you can simplify those, simplify them. So x plus 3 over 2 and x plus 4. Now the good part of this one is that one of them looks like a good number, the other one doesn't. So how do you change it? You're looking at doing this. If they're fractional numbers at the end, you take that bottom number and you swing it back in the front of that particular factor. If the other one's simplified like it did this time, you don't have to do that twice. You only do it within the factor that you're looking at. So this one, the completed factorization is 2x plus 3 and x plus 4. Now, if you FOIL that out, first, outer, inner, last, it should equal what we had at the beginning. If you were to FOIL out x plus 3 times x plus 8, you definitely would not get what we got at the beginning. You would get x squared plus 11x plus 24. So the end result looks quite a bit different than the beginning. So let's look at another one when the signs are a little bit harder. So 4x squared minus 4x minus 3. So at the end, what are we going to divide by on this one? 4. So I'm going to circle that one in a different color. Then we multiply the 4 times the negative 3, and we get negative 12. So we are looking to factor x squared minus 4x minus 12. Anybody think of the factors of negative 12 that add up to negative 4? Negative 6, positive 2. Again, if you can't get that out of your head, you're just going to do, okay, I need factors of negative 12. That would be one of each of the signs. Since the middle term is negative, the largest is negative. And then you could do your table from there. It is x minus 6, x plus 2. Here's where we're ready to divide by 4. So that number that we had at the beginning, we're dividing by that. This time the numbers don't look quite as nice. Simplify it if you can. X minus 3 over 2, x plus 1 over 2. Now, we don't want to leave them fractions, so what do we do now? Swing the 2 to the front of each of them. Sometimes the numbers are different, like if one was a 2 and one was a 3, you'd swing each of those numbers and that's what it would look like. So whatever number's on the bottom, you're going to swing it back up. So our final answer looks like this. 2x minus 3 and 2x plus 1. So do you guys remember that from Algebra 1? Yeah? Hopefully it's coming back if you've forgotten that one. Let's see how many more. This is something a little bit different. You can write these down if you want to, but you won't necessarily have them on the test because you have used them before. If you see something like a plus b, the quantity squared, you would FOIL it out and you would get a squared plus 2ab plus b squared. Same thing if you had an a minus b or an x minus y or whatever. You'd have a squared minus 2ab plus b squared. So what we're going to be looking for in this one is when I see something like that, how do I factor it? And it's something that you kind of just have to recognize, and I'll kind of show you what to do. So we're going to kind of look at these formulas, and they're perfect square trinomials. If we look at these, you want to look at the 4x squared, and you want to recognize that those are both perfect squares. 2 times 2 is 4. X times x is x squared. So this one really looks like a 2x squared. 36 is also a perfect square, and that one can be written like 6 squared. So in this one, now I'm just strictly going with the formula. Once you get used to it, of course, you don't have to assign anything anywhere. So if I'm looking at the formula at the top, it follows the one on the bottom, right? Because there's a minus in there. So my a this time is going to be 2x, and my b is going to be 6. And anywhere in the formula, then you're going to put those in, okay? So it looks like this. Okay, so it looked like this to start out with. It looks like that when you end. Okay, so you're going to have two things that look exactly the same. And if you FOILed it out, you'd have 2x times 2x would be 4x squared. 2x times negative 6 would be negative 12x, and you do that twice, so you'd have negative 24. And then negative 6 times negative 6 is 36. So it does work. It's just you have to kind of recognize. So what you look at first is you look at this one, and you look at this one to see if they're perfect squares. If they are, it follows one of these two formulas at the top. So let's look at another one. Okay, so is 64x squared a perfect square? It is, right? What's the square root of 64? 8. So we're going to go 8x. Since there's a minus in the middle, the sign in the middle is minus. And then what's the square root of 1? 1. And that's it. So here I didn't write what a was. This time a would have looked like this. 8x squared, so a is 8x. 1 can be written as something squared, so b is 1. Okay, so if you want to assign them, you can. If you can do it without, that's fine. And of course, you can FOIL it back out. Write this one down too. This one you haven't seen for a little while. Difference of two squares. Notice on this one, if the first term is squared and the second term is squared and you only have the two terms, they look the same except the signs are different in the middle. It's kind of like the signs have to be different because those middle terms cancel out. So this will be one of them where there's only two terms that you're looking at. There won't be 3. So it's kind of easy to recognize. We did one at the top that had 2 terms, but it wasn't something that looked like this. I'll scan up to that one here in a minute. That one up at the top wasn't perfect squares. This one is. So when you look at the numbers, I'm going to look at the form as well. Here, a would be 5x, because you take the square root of 25 and the square root of x squared. B would be 7, because the square root of 49 is 7. And since it's a minus, there's one of each. 5x plus 7, 5x minus 7. So no tables, no nothing for these. In this one, what I think when I see it, I'm like, oh, those are perfect squares. There's none in the middle. One of each sign. And you square root both of the terms. Okay, what about this one? What's the a going to be? 4x. And what's the b going to be? 9. So square root each one. And do we have one of each? Yes. So 4x minus 9. 4x plus 9. Doesn't matter which one you put where, because they are being multiplied. Okay, that's it. So, do you guys want to practice another one of those swing ones? Or do you get it? You could practice them on your own, and if you have questions, we can do more up here if you need to. The assignment is slightly different from Sunday because I did take a couple off of the assignment yesterday. So I think it's just the 2 at the beginning. But they're kind of like the ones where you have to factor something out. It's not like the swing ones. So be ready for the test on Thursday. It'll be reviewed tomorrow. And I will put a study guide online for you in a minute.